Hi everybody and welcome back. We're continuing our Chapter 6 discussion on forces, and this force today, in this video that we're going to be talking about, is friction. Now, excuse me, friction is kind of interesting in that it doesn't really exist as an independent force, but it simply exists to oppose other forces. For example, if you have a box sitting stationary on a tabletop, there is no friction because nothing's trying to move it. But only when you have some force trying to move the box do you get a resisting force of friction. Now, you'll notice that the initial force right here, I wrote with a capital F. That may have any subscript that you want to put. That's an actual force that's trying to cause the box to move. This friction force, and I'm calling it F sub R right now, is lowercase. And I do that to indicate that it really only exists to oppose other forces. Why does friction exist? Well, if you look microscopically between two surfaces, no two surfaces are perfectly smooth, and there's always some degree of little hills and valleys in here that catch and kind of create these resisting forces to the motion of the object. So, up to this point, we've kind of thought of smooth surfaces like ice as being frictionless, but even ice has friction. So later on, we're going to talk about different kinds of friction with different subscripts, but just in the generic sense, we're going to look at friction, or I'm going to notate friction as being lowercase f sub r, all right, and it opposes motion. So right here we have two forces that are acting on this box. Let's pretend this force right here is, I don't know, 3 newtons, okay? And the friction force is 1 newton. Well, you notice they're in opposite directions, and so you might say the net force on this box equals the regular force minus the friction force. So that would be 3 minus 1 equals 2 newtons. All right, so even though 3 newtons are being applied to move this box towards the, we'll call that, well, towards the left, this 1 newton of resisting force or friction force is holding it back so that the net force is less than it would normally be. So how does friction work? Well, it can work to slow something down. All right, but I'm going to do a couple little examples on the next page of how friction can be the only force causing something to move. So I got a blank slide right here. Let's pretend that you are sitting on a I don't know, a wagon. All right, so this is you right here. You're sitting, and on that wagon, I'll draw the wagon as a different color. We'll make it blue, I guess. Okay. That's your wagon right there, and it's got wheels, and it's rolling like so. Okay? The wagon is moving. The whole acceleration that system is, we'll say it's accelerating at 3 meters per second squared. All right, so you would, in order to know what force is being applied, you would have to know what the mass of the whole system is, such that if you applied that force to that whole mass, you would get that acceleration. All right, but here you're applying the force to the wagon. What is causing you to move? What's causing you to move? Well, let's pretend for a second that somebody had sprayed oil or grease all over the surface of the wagon right there, okay? And you were sitting in it. What would happen if, we'll say, that wagon was pulled very forcefully forward in that direction? That's the wrong color. Well, you know that from Newton's first law, it would probably mean that, especially if this surface were virtually frictionless, or oiled or greased, the wagon could very well be pulled out from under you because you have, according to Newton's first law, you have inertia, right? So why do we generally not want to sit in oil or grease if we're sitting on a wagon? Well, probably because you don't want to sit in oil or grease to begin with, but the point is that you actually want friction to work for you. Let me redraw this again real quick here. All right, so there's our wagon, and here's you sitting here on the wagon. All right, and the wagon is moving. Ooh, I want a red wheel. I want a blue wheel. And the wagon is moving towards the right. There's a net force applied to the wagon right there, okay? And the wagon is moving. Well, what's causing you to move? The reason I drew a wagon was because, or you might say a flat thing, is because there is no back to it. There's no back to your seat. What in a car, what makes you move forward is the fact that your seat is pushing against your back, which is why you feel that pressure when the car accelerates. But what is causing you to move forward here? Well, as the wagon attempts to move forward, and you try to move backwards because of inertia, right? What's preventing you from moving backwards? Well, friction is. Friction is preventing you from moving backwards. So I'm going to draw friction as, we'll call it green right here, all right? It's really the friction force between you and the surface of that wagon that is really moving you forward and causing you to accelerate with the whole rest of the system. If not for that friction helping you forward, you would just slide off the back of the wagon and then the wagon would move forward without you. So, in this case, the reason you have a net acceleration, or you may say the acceleration of the system of you of 3 meters per second squared, is because you have a net force acting on you to move you forward. All right, the net force on you of the system of you equals the friction force, and there is nothing else. Yes, I'm sorry, there are forces acting in the y direction, but you're not moving up or down, you're moving horizontally. So I should say net force of you in the x direction is the friction force and nothing else. That is why you're moving forward with the cart. And that is why you have the same acceleration as the rest of that car system right there. We often tend to think of friction as being something that slows us down, but in many cases, friction can be good for us. It helps us move forward. It actually helps you to move forward. Let's say if you're walking. All right, here's your change colors to blue. All right, so you're walking right here. All right, and there's your legs, and as you move forward along the ground, what propels you forward is the fact that you're trying to push your foot backwards against the ground, and the ground says, oh, no, you don't. There's friction between you and me, and instead of you sliding backwards on the ground is pushing you forwards due to friction. That's what actually makes you move. That's what makes this person on this cart move. Friction is moving them forward. And so friction is really not, well, I should say it's not exclusively something that slows you down, but it can actually help you move forward. To be sure, friction is something that keeps you on the road. Friction between your tires and the road keeps you on the road going around the corner, and we'll talk about that a little bit later as well. But you're going to be seeing some problems in homework where friction is the only force acting on something to move it forward, and you're going to need to find out what that is to solve for it. So that's a little bit about friction. Look for some other videos on friction problem examples in your notes or examples from your homework, problems from your homework, and please be sure to contact me if you have any questions. Thanks for watching. I'll see you on the next one.